Okay, I'd like to do an example of a distance rate time problem from page 574. This problem is number 60. Two planes start from same airport, fly in opposite directions. The second starts a half an hour after the first, and its speed is 80 kilometers per hour faster. Find the speed of each plane if at 2 hours they are 3,200 miles apart. Now, in this section of the book, we're using two variables, x and y, so it makes sense to solve this problem using two variables. So let's first state what we're going to do. So let's use the variables for the rates of the plane, because that's what they're talking about in this first part. So let's say that the first plane is x, and the second plane is y. And then if we go back to reading the problem, it says that after the second plane starts a half an hour after the first, but its speed is 80 kilometers faster. So, does x equal y here? No. Which plane is faster? The second one. So, if I took the second speed, subtracted the first speed, I should get 80, because the second one was 80 kilometers faster. So there's a simple linear equation representing that statement, or the difference of the two speeds is 80. Now, what else do they tell me? Find the speed of each plane if after 2 hours they're that distance apart. So we know that distance equals rate times time, right? So, what's the time? Well, there's two different times because there's a half an hour difference, right? So the first plane had a time of 2 hours, so 2 times x. The second plane, half an hour after the first, so 1.5 hours times its rate. And if I add the rate times time of the first one, that's distance for the first plane, plus the distance for the second plane, it should equal 3,200. And there I have a nice system to solve. And you know how to solve a system, right? I could multiply the first one by 2, and let's switch the variables a little bit. So if I times that one by 2, it'll give me negative 2x plus 2y equals 2 times 80, 160. Oh boy, now we're easy. If I add these two equations, the x's disappear, right? So I get 3.5y equals, what happens if I add those? 3360, check my adding. All right, solve for y, so we'll divide by 3.5. You have your calculators handy, I hope. So divide by 3.5, and we get y equals what? 960. So, the rate of the first plane is 960. How can I find the rate of the second plane? Go here, right? Y is 960. 960 minus x equals 80. That's easy, huh? X equals 880. Check my arithmetic. Using two variables to solve this problem. I know in Algebra 1 we used to do a distance rate time chart, and you could have solved it all in x if you wanted. But I like to stick with the method in the chapter. Good luck.